Linux architecture. When we talk about the Linux architecture, we have to focus on what's known as the kernel. Now, the kernel is really the heart of everything that runs on Linux. And so imagine you have got these applications and they are all using the kernel to get things done. That is just what they do. Now that kernel again being the focal point, it is going to give us access to different area of that computer. And so again these applications are calling the kernel, and the kernel is helping them to get these things done. Now those applications that are running on this kernel, well, when we back up and look at it at a high level in terms of just Linux, these applications are maintained by different communities, and those communities, when we put them together, they distribute their own packages or their variety of Linux, and we call those distribution. So Red Hat is a distribution, Debian, Mandriva, CentOS, Ubuntu, and so these different distribution take that Linux kernel and they put their package on top of it. They put their different applications that are going to make use of the kernel, and then they distribute that. And that's how Linux is viewed and operates and is used today. Now, at a high level, if we were to just look at a system architecture, ignoring whether it is Ubuntu or Red Hat, there are three elements that we want to understand. The first element is the user space, the second element is the kernel space, and the third element is the hardware. Now we need all of these to be able to do anything in any computer. And that doesn't matter whether we are using Linux or if we are using a cell phone that has got an operating system on it. There is a user space, there is some kind of background kernel space, and then there is the hardware that we work with. Let's break each of these down. So beginning with the user space, here we are browsing to a web page. There is an application that is making use of the user space. We might open up a terminal, and in terminal we are accessing the shell or the command line. This again is the user space. It is important to understand the user space is what we work with as a user. The graphical desktop environment, that graphical desktop environment, depending on the distribution, might be GNOME or it might be KDE, or there are some other type of SEP graphical environments out there, but those are two of the common ones. At the user space, we separate the memory that the user is using from what the kernel is using, and this prevents these processes like this command line here from interfering with what the kernel is doing in the background. We have function calls and programming interfaces that are used for communication between the user and the kernel space. Now in the kernel space, this really figure out which process are able to do things like access the CPU. So we handle the system calls in the kernel space. We have process management that is handled in the kernel space, and we have device drivers that are handled by kernel space. So everything that has to do with all processes that are running all these applications, and then the functionality that access the hardware, also memory management would be something that we would see here. So now discussing how the kernel and the user kind of relate to each other and how they access the hardware, we can imagine it like this. We have a user that is accessing this computer that is running Linux via a GUI interface, graphical user interface, some type of desktop environment. Now they need access to the hardware, right? Maybe they need to print, and to print they are connected to a printer that is off a USB port. Well, they don't have direct access to that hardware. The kernel is going to handle that, and the kernel is going to handle the multitasking. So this user access the hardware via the GUI, the kernel is what really provides that and then give us access. So another example would be the network card or the CPU. See, without that kernel as that go between, then we are not able as a user to have that direct access to the hardware. It really doesn't make much sense for us to have access there. So the kernel is going to handle these different process threads. These process threads are going to grant CPU resources and make its memory space available to the CPU. So it is the kernel that is handling those threads which are giving us access to different hardware, perhaps the same time as our user is accessing all of these resources via the GUI.